Today, we're going to start by looking at key features of functions. If you recall in eighth grade math, in Algebra 1, you study functions, you identify functions. Functions are a special relation. A relation can just be a list of ordered pairs, but it's special in that each x is paired with only one y. You recall that? The x's don't repeat. If it's graphed, it passes the vertical line test. So some of that should be coming back to you as we talk about this. These first blanks here are vocabulary that we're going to review. The first one being the domain of a function is a set of all inputs or x values of a function. Okay, so we're going to be finding the domain in some of these graphs below. So we're going to be looking for those x values. Second vocabulary, the range of the function is the set of all outputs or y values. So in the first set of examples here, we're going to find the domain of each graph below. So let me scroll down a little bit here and see those examples. Number one, the domain, right? We're talking x values. So looking at my x axis there, this graph goes all the way over here on the left to -8. That's as low as the x values go. And then it travels a ways all the way up to +8. Do you see that? So there's two ways we can write this. We can use interval notation, which is oftentimes my students' favorite way to write it. It's kind of a shorthand way. Interval notation is going to use, let's use brackets. When it's a closed circle like we have here, we're going to use brackets around it, or parentheses if it was open. And I'll illustrate that here in a second. So using that interval notation, as far left, our lowest value, our smallest value is -8, and it's a closed circle. So we use a bracket around -8 to show that -8 has a closed circle, meaning it's included there. And then it travels all the way, we're going to put a comma, all the way to +8. And again, we had a solid circle there, so enclosed with a bracket. That's interval notation. Again, a lot of students end up liking that. You'll see that modeled on Delta Math as well. Set notation is going to use inequality symbols. So we went from -8, smallest value, is less than or equal, because we have the closed circle, for our x values ranging still less than or equal to +8. Okay, so those are the same way to write this. You don't need to write both. Pick one that you love, and you can stick with that. Okay, so interval notation, shorthand, brackets, or you'll see the parentheses here in a minute. Set notation using inequalities. One or the other. You don't use both. You can use them interchangeably, but pick one that you like, okay? Let's look at a couple more examples to just solidify what we're doing here. So number two, we have open circles. Let me use that blue again. We have open circle all the way here left to -10. That's the lowest on the domain, all the way up to +10, okay? Those are our x values. So let's use interval notation. Open circle, so parentheses for -10, comma, all the way to +10, again, another open circle. Okay? Set notation with those inequalities. We're starting at -10 is less than x less than +10. I didn't use the equals because we have the open circles. And the open circles say, hey, it goes all the way here, but it doesn't include -10, or it does not include +10. It includes 9.999999, but not 10. So in order to show it on a graph, I'm going to use an open circle to show you we get very, very, very close to 10, but we're not including 10. Okay. Notice I keep using less than symbols. Just use less than symbols as long as you're going in order from least to greatest. I always start with my smallest value far on the left, and as I move to the right, using my biggest value, those inequality symbols stick as less thans. I'm also writing x in the middle for our domain, our x values. Last one goes all the way from -11 all the way to +11. Ignore my scratch there. Let's see, we have open circle, so parentheses at -11, all the way to +11 with a closed circle. So make sure you interchange those. We use parentheses to start with the negative, bracket on +11. That set notation is going to look like -11 is less than x is less than or equal, right, to positive 11. There you go. Interval notation, set notation, looking at domain, the x values. Let's scroll down. We're going to do the same thing, but with range. Determine the range of each graph below. We're looking at the y values, up and down. How low does it go to how high? So our first graph, switch your brain. We're looking at our y-axis. How low does it go? Way down here at -9. How high does it go? 0. You see that? Okay, interval notation. We went as low as -9. You want to start with smallest value, right? -9. It had a solid circle there, and it also dipped. If you ever have a graph that dips at your lowest place or your highest place and doesn't have a point, the dip is also inclusive. So a bracket or an equal sign, okay? As high as 0, we had a solid circle. It also passed, so bracket. Set notation with the inequality symbols, we went from -9 is less than or equal to, watch out, here we go, y. Why? Why did I put a y? Because we're talking about the range, about the y values. So let me add that to our notes. We are talking about the range. So make sure you put a y value. Okay, keep going. We'll have less than or equal 0. Set notation, -9 is less than or equal to y, less than or equal to 0. Number 5, how low does it go? -9, didn't quite get it on there, as high as +9. Set notation, -9, you want to do your lowest, smallest number first. -9, this is what I was talking about. It's inclusive. Use that bracket. It dips. It goes through there. There is a solid circle. There's an included point there. -9 all the way up to +9. Again, passed through, so bracket. You see that? Don't get caught up in your endpoints. Really look at the full graph. Did it go higher or lower than the endpoints? So set notation with those inequalities from -9 is less than or equal to y, less than or equal to +9. Our last one, how low did it go? It has an open circle at -2. And we have closed circle at +10. How low does it go? -2. How high does it go? 10. Interval notation, -2, but it was open circle. So parentheses, -2, up to that +10, and it had a solid circle. Set notation, -2 is less than y, less than or equal to 10. Again, these are two different ways you can write your domain or range, interval notation or set notation. You don't have to use both. You can use them interchangeably, but pick one that you love, and Delta Math will work with you on that. On the second page of our notes, we're going to look at when a function is positive or when it is negative. So number 7, A says the graph of y equals f of x is shown below, shown to the right there. We're going to use that graph. Find all the values of x, or the domain, for which f of x is less than 0. Remember, f of x can mean the same as y. We're looking at our function when it is less than 0. So really simple here. I'm going to highlight for us. Anywhere that our graph is above the x-axis is positive. Anywhere that our graph is below the x-axis is negative. So in our question here, we're being asked to identify all the x values or the domain where our function is less than 0 or where our function is negative. So we're talking about from here to here. I'm going to highlight it there in green. We're talking from where x was 3 to where x is 7. That little segment there is the x values, or would be the domain, when our f of x is less than 0 or negative. So let's list out our answers here. We can use set notation or we can use interval notation. We are going from 3 to 7, using parentheses there because we're not including those actual points because that's where it switches from negative to positive. Or you can use that other notation, 3 is less than x is less than 7. Whichever one you want to use on Delta Math will work. So let's go down to B. Just below, we're going to use the same graph for part B. The question says the graph of y equals f of x is shown below. We're going to use it right there above. Find all the values of x for which y is greater than 0. Tell me all the places where it is positive. So we've got two sections, right? We've got this left side and this right side that are above the x-axis that are positive. The left side is going all the way to negative infinity. It's inching out ever so slightly to the left. So the domain is going towards negative infinity on that side. And on the right side, it's also inching out ever so slightly on the x-axis towards positive infinity. So we've got a little bit of a trick here. Let me show you how we're going to write this. If you want to use the interval notation, we're going to use parentheses, negative infinity to 3. Combine that with the word or. On Delta Math, there's a button to click for or. And we'll have 7 to infinity. So a couple things here. Notice I used parentheses around that negative infinity and positive infinity. We always use parentheses because we can't get to the end of it. I can't include it. So don't ever use brackets there. Always use parentheses around your infinities. And then again, I said we're going to combine those two segments with the word or. And there's a button for you on Delta Math. We can also write it with the set notation, all the x values that are less than 3, or all the x values that are greater than 7. There you go. Let's look at number 8. Number 8, same concept, same type of question. This is just the different way Delta Math asks the question. So you might see this variety. Number 8, part A, determine the domain for which the graph of f of x is negative. Much simpler wording there, right? So I gave you the hard stuff first. Same concept, just doing it with this easier writing here. Again, still positive above the x-axis, negative below. So for part A, the area that is negative, again, right here, x values here is -5 and -1. For that interval notation, we have from -5 to -1, set notation, -5 is less than x is less than -1. Part B, determine the domain on which f of x is positive. Those two upper sides, right? Again, arrows, left side to negative infinity, positive, right side, left side to negative infinity, right side to positive infinity. For that interval notation, negative infinity to -5, or -1 to infinity. Or if you want to use that set notation, we're going to say x is less than -5, or where x is greater than -1. So we've got a graph that's a function that is graphed below. Identify each interval or segment as positive or negative. And then the other words we're going to look at is increasing or decreasing. So we're using the same concept above here, positive or negative, that I underlined in green. We're also going to say increasing or decreasing. This is no brainer. It's the same as slope. Now remember to always read your graph from left to right. Just like you read a sentence or you're reading a book, we look at our graphs from left to right to determine whether they're going up, increasing, or down, decreasing. So let's look at a couple of these. You ready? Part A, what is true about the graph on the interval from A to B? We are right here. Is it positive or negative? It's above the x-axis, therefore it's positive. Is it increasing or decreasing? Again, look at it from left to right, like I'm reading a sentence. It is going up, so increasing. Done. On Delta Math, this is like a multiple choice selection. Very simple. What's true on the graph from D to E? We're looking at that next question. D to E, highlighting here. Is it positive or negative? It's below the x-axis, therefore it's negative. Increasing or decreasing? It's going up from left to right, so increasing. C, what is true about the graph on the interval from negative infinity to A? So this is negative infinity to A. this segment over here. I wanted to make sure you got to see examples that have that infinity or negative infinity. So we're talking about that very first segment. Is it positive or negative? It's below the x-axis, so it's negative, and it is increasing. D says from the points C to D, highlighting it there in blue, it is below the x-axis, therefore negative, and it is decreasing. Do you see that? It is falling from left to right, decreasing. This is our first decreasing, isn't it? E, what's true about points F to G? F to G over there in purple, it is positive because it's above the x-axis, decreasing because it's falling from left to right. And F, what's true from G to infinity? That last segment here, again, wanted to make sure you saw those examples with the infinities there. It is positive because it's above the x-axis, and it is increasing because it is going up from left to right. Again, on Delta Math, those are just multiple choice. Very easy. And that concludes our notes for key features of functions. We briefly reviewed, hey, a function is a special list of ordered pairs where the x's don't repeat. Each input has only one output. If it was graphed a vertical line test, it would only touch once. But mostly reviewing the vocabulary domain and range, identifying those from the graphs. We also included talking about interval notation versus set notation. Wanted to make sure that y'all saw that because sometimes they will use one version or the other on test benchmarks, our state, T, and ready. And so I want to make sure that you have seen that and you feel comfortable with that. And you get to choose which one you prefer to use on Delta Math. So we found the domain, we found range, we talked about open and closed circles there. Make sure if you're using set notation when you're doing your range, put in that Y or you'll have some mistakes there. The latter part of our notes where our graphs are positive or negative, if they're increasing or decreasing. Very simple there. A little tricky when we're writing our domains and there's two parts. Again, Delta Math has an OR button. You can just hit that OR button to connect those two segments. So y'all let me know if you have any questions. We'll be talking about this in class, and I'll see you later.